Okay, in this video we're going to look at questions 11 and 12 on the worksheet. Question 11 says, suppose the Taylor series for a function f centered at a equals 1 is 3 minus 4 times x minus 1 plus 2 times x minus 1 squared minus 3 halves times x minus 1 cubed. Part A says, find the Taylor polynomials p0, p1, p2, and p3 for f centered at a equals 1. Okay, well first off, recall the general form of the Taylor series of f centered at a equals 1. This by definition is f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 over 2 factorial times x minus 1 squared, so on and so forth. Okay. Also recall that the Taylor polynomials are the partial sums of this Taylor series. So in other words, p0 of x, that's this constant term f of 1. p1 of x, that's where we sum up to the linear term. p2 of x, that's where we sum up to the quadratic term. p3 of x, that's where we sum up to the cubic term, so on and so forth. So looking at this given series here, we can see that p0 of x, that's the constant term 3. p1 of x, we go up to the linear term, so we get 3 minus 4 times x minus 1. p2 of x, that's where we go up to the quadratic term, so we get this. And p3 of x, that's where we go up to the cubic term. All right, cool. Part B, it says, what's the value of f double prime of 1? How about f triple prime of 1? Well, the idea here to find f double prime of 1 is to first notice that f double prime of 1 shows up as part of the coefficient of x minus 1 squared in the general form of the Taylor series of f centered at a equals 1. And from the given series, right, we can see that that coefficient has to equal 2. So the idea here is to equate these two quantities. So in other words, f double prime of 1 over 2 factorial, this must equal 2. And now if you multiply both sides by 2 factorial, okay, you can conclude that f double prime of 1 is equal to 4. All right, now for f triple prime of 1, it's basically the same idea, right? F triple prime of 1, it shows up as part of the coefficient of x minus 1 cubed in the Taylor series. And from the given series here, right, I can see that that coefficient must be negative 3 halves. Quantities must be the same. So f triple prime of 1 over 3 factorial, that's equal to negative 3 halves. Now if you multiply both sides by 3 factorial, and note that 3 factorial is equal to 6, you get that f triple prime of 1 is equal to negative 3 halves times 6, and that's equal to negative 9. All right, cool. Well, that does it for question 11. So let's press on to question 12 here. So for 12, it says, the graph of a function f is shown to the right. I've included it up here as well. Okay, part A, it says, explain why the series 1.6 minus 0.8 times x minus 1 plus 0.4 times x minus 1 squared minus 0.1 times x minus 1 cubed, and so on, is not the Taylor series of f centered at a equals 1. Okay, so we're going to use pretty much the same idea that we did in question 11 part B. Okay, so if this were the Taylor series of f centered at a equals 1, we would have the following, right? F of 1, that must be 1.6. Negative 0.8, that would have to be f prime of 1. 0.4, that would have to be f prime of 1 over 2 factorial. Negative 0.1, that would have to be f triple prime of 1 over 3 factorial, and so on. Okay, so do any of these look problematic? Well, could f of 1 be 1.6? Well, I can't tell exactly what f of 1 is. Plausible that it's 1.6. It's clearly larger than 1. Okay, what about f prime of 1 equaling negative 0.8? Is that a problem? Well, yeah, that is a problem. It's a problem because I can see that the slope of the graph of f is positive at x equals 1. In other words, f prime of 1 is greater than 0. Okay. However, if this were the Taylor series of f centered at a equals 1, right, this would imply that f prime of 1 were negative 0.8, and that just simply can't happen. All right, cool. So for part B, pretty similar. It says, explain why the series 2 plus 0.5 times x minus 2 plus 1.5 times x minus 2 squared minus 0.1 times x minus 2 cubed, and so on, is not the Taylor series of f centered at a equals 2. All right, well, here we are on the graph when x is 2. And if this were the Taylor series of f, centered at a equals 2, just like we saw in part A, right? This 2 would have to equal f of 2. This 0.5 would have to be f prime of 2. This 1.5 would have to be f double prime of 2 over 2 factorial. Then this negative 0.1 would have to be f triple prime of 2 over 3 factorial, so on and so forth, right? So do any of these look problematic? Well, how about f of 2 equaling 2? Again, yeah, it looks at least somewhat plausible. Not really raising any red flags there. How about f prime of 2 equaling a half? Well, again, that doesn't look too problematic because I can see that the slope of the graph of f is positive when x is 2, so that doesn't seem to be a problem. How about f double prime of 2 over 2 factorial equaling 1.5? Yeah, no, that's a problem. Why is that a problem? Well, the graph of f at x equals 2 is concave down, okay? And so that implies that f double prime of 2 is negative. But see, if this were the Taylor series of f centered at a equals 2, okay, then I would have f double prime of 2 over 2 factorial to be equal to 1.5, which would imply that f double prime of 2 would be what? It'd be 2 times 1.5, or in other words, it would equal 3. And see, can't have that happen because I know the second derivative at 2, it has to be negative. Cool. All right, well, that's going to do it for these two questions. I will see you in the next video. Thanks.